Hey guys, in this video I'm going to be going over the factoring examples in the Precalc Advanced Summer Packet. So the first one, example F, it says factor each expression completely. So if we were going to factor that, it's a difference of perfect squares. If you notice, 100 is a perfect square, so is a squared. 4 is a perfect square, so is b squared. So anytime you have a difference of perfect squares, you can split it into two sets of parentheses. And to get the first term in each parenthesis, you have to take the square root of the first term. Square root of 100 is 10. Right? And the square root of a squared is a. So 10a is the first term in each parenthesis. The second term in each parenthesis is just the square root of the second term. Square root of 4 is 2. Square root of b squared is b. So 2b is the second term in each parenthesis. And then anytime it was a difference of perfect squares, there's a subtraction sign. You could put one minus sign and one plus sign. And that's your answer. If you want to check your answer, you could always FOIL that back out and see if it's exactly what you started with. So I'm going to check it. 10a times 10a is 100a squared. The outside terms, 10a times 2b, 10 times 2 is 20. A times b is ab. The inside terms, negative 2 times 10 is negative 20. And b times a is ba or ab, doesn't really matter. And then the last terms, negative 2b times 2b is negative 4b squared. If you notice the middle terms are like terms, they end up canceling out. And if you look at your answer, 100a squared minus 4b squared is exactly what you started, so you know that you did it right. And of course, what I boxed is my final answer. Example G says factor each expression completely. So if we were going to factor that, we should split it into two sets of parentheses. You can split the x squared into x and x. Then you need to think about numbers that multiply to 72, but also add to negative 17. So I think it would be wise to make a list of numbers that multiply to 72. Like 1 times 72, 2 times 36, 4 times 18, 6 times 12, and 8 times 9. And usually what I do is I ignore the negative temporarily and I say, which one of these pairs of numbers adds to 17? Or maybe which pair of numbers can subtract to 17. And if you look, 8 plus 9 does add to 17. So put those in here. 8 plus 9 is 17. And then last thing, I look at the signs. I want it to multiply to be a positive number, add to be a negative 17. Seems like we can make them both negatives. Negative 8 times negative 9 is positive 72. And the middle terms, negative 9x and negative 8x, add to negative 17. That would be your final answer. And of course, if you want to check it, you can just FOIL it back out like this. X times x is x squared. The outside terms get you negative 9x. The inside terms get you negative 8x. And then negative 8 times negative 9 is positive 72. Could go ahead and add those like terms. You get x squared minus 17x plus 72. Double check that what you ended with is what you started with. If it is, you know that you did it right. Example H says factor each expression completely. I'm looking at that. There's 3 different terms. Terms are separated by a plus or a minus sign. And I'm looking and they all have a 3 in common. So we might as well factor a 3 out first. That might make our work a little bit easier. If we factor a 3 out of 3x squared, we're left with x squared. We factored a 3 out here. Think 3 times what gets you negative 9? It's negative 3, and we need that x. And then 3 times what gets you 6? 3 times 2 gets you 6. So that at least makes this a little bit easier to factor. We're not done. It says factor completely. We can factor this further. Make sure you write the 3 down. It's important to keep it there. We can now split the x squared into x and x. Now we need to think about numbers that multiply to positive 2 but add to negative 3. So the only numbers that multiply to 2 are 2 and 1. If we want them to add to negative 3, they should both be negative. And that is our final answer. Of course, if you wanted to check, you could FOIL these back out, add your like terms, then you could distribute the 3, and you could double check that it equals what you started with. Example I is next. It says factor each expression completely. So if you look, all the terms don't have anything in common. So think, this is going to be one where we have to guess and check. I'd make sure you're using a pencil in case you make mistakes. But to split up 2x squared, there's only one way. Split it up into 2x and x. And then we need to think about numbers that multiply to 27. Again, it can't hurt to make a list. 1 times 27 and 3 times 9. Just in case you guess and check and it doesn't work, the list helps you to kind of keep track of what you've guessed and what else you have to kind of pick from. So we need to pick between these numbers. We need to make sure our middle term adds to negative 15. So I might pick 3 and 9. All right, if we put a 9 and a 3 in here, let's just kind of ask ourselves, our middle terms are 9x and 6x. 9 plus 6 is 15. But we want it to be negative 15, so we should make both of these negative. That looks like it should be our final answer. I'm going to put a box around it. I would make sure you check your answer, FOIL it back out, double check that it equals what we started with. So if we're going to check this off to the side, 2x times x is 2x squared. The outside terms get you negative 6x. The inside terms get you negative 9x. And the last terms, negative 9 times negative 3 is positive 27. You could then add your like terms. Negative 6 and negative 9 is negative 15. So you end up with 2x squared minus 15x plus 27. Take a good look. Is that what you started with? If it is, you know that you did it right. All right, last factoring example. It says factor completely using the GCF. GCF stands for greatest common factor. So we're going to be looking at these two terms. Again, terms are separated by either a plus or a minus sign. And I look at what they have in common. All right, first I would focus on the numbers, 36 and 18. What do they have in common? They both have a 9 in common. X to the third and x to the fifth. They have 3 x's in common. And y to the ninth and y squared, they have 2 y's in common. So anything they have in common, we're going to take out. So we said we could take out a 9, 3 x's, and 2 y's. All right, and then we have to write in parentheses what we're left with. So I like to think 9 times what gets you 36? It's 4. If we took 3 x's out, and that's all there is, there's no x's left. We had 9 y's, we took 2 out. There's 7 left over. Next, I like to think 9 times what gets you 18? It's 2. There were 5 x's. We took 3 out, so there's 2 left. And then there were 2 y's. We took both of them out. That's all there is. All right, that is your final answer. Again, to check, just distribute. See if you get what you started with. 9 times 4 is 36. X to the third. And if you do y squared times y to the 7th, they have the same base. You're allowed to add their exponents. That would be y to the 9th. Plus, now distribute this to the 2x squared. 9 times 2 is 18. X's, they have the same base. You're allowed to add their exponents. 3 plus 2 is 5, so that's x to the 5th. And then y squared. Double check that this is exactly what you started with. If it is, you know you did it right. That's all for factoring. Hope this video was helpful.